Hello, college algebra students. We are back and we are talking about rational word problems. And it is probably in your best interest that you make sure that you have got a calculator um, at your disposal and that you're ready to pause things to make sure that you can get these correct answers in your calculator as well. Um, Fun fact, most of the word problems that we're going to look at are simply just plug and chug problems. There really isn't anything overly intellectual about them. And you are either going to plug in values for either the x or the y, the input or the output, or you're going to be evaluating asymptotes. And most likely you'll be evaluating your horizontal asymptotes. Here's question one. A utility company burns coal to generate electricity. The cost C in dollars of removing P% of the smokestack pollutants is given by this equation. So again, C is the cost and P is the percentage that you're able to remove. So look, percentages, you're either able to remove 0 to 100% of pollutants is kind of what they're talking about. You are a member of the state legislature considering a law that would require utility companies to remove 90% of the pollutants from their smokestack emissions. The current law requires an 85% removal. How much additional cost would the utility company incur as a result of the new law? How much more is it going to cost? So I need to find the cost at 85% and the cost at 90% and figure out what the difference is. Let's subtract them in essence. Okay, so to figure out the cost at 90%, I'm going to take my equation, 80,000, and my percent here is just 85. Okay, it tells you P%. So when you plug in P, you just remove the percentage. So 85 over 100 minus 85. Now, things to think about when you deal with rational equations, you ought to make sure you've got parentheses as much as you can. I really recommend that you put parentheses around everything in the numerator and then everything in the denominator. Okay, here's where I hop to my calculator. So I'm going to plug this into my calculator. Keep up, I'm already kind of got it there. So 80,000 times 85 divided by 100 minus 85. Ooh, I don't want that as a decimal. Shoot, I want that as a decimal. Um, Bummer. Okay, let's try settings. Handheld. That's not what I want. So let's try settings. That's not what I wanted. Document settings. Interesting. Okay, let's go back here and let's go back to this one. I'm going to go, I should be able to do, let's go back up here. I'm going to type in here 85 decimal. How about 85 decimal? Why won't it let me redo it? This is not making me happy. All right, well, let's go back down here. I always recommend that you type in things as much as you can. This is times, I'm going to do 85 decimal point. A lot of times adding in a decimal point will mean that your answer overall is going to give you a decimal type of an answer. All right. Hey, that's better. It looks like it's going to be $453,333. I would really prefer more decimals. And I am not having a good time with this. Handheld setup, document setup. I want it to float 6. Let's just go with float. This is not the way I wanted this to be. I should just be able to press like Control Enter, and there we go. Okay, so we should have 45,000. I want to go to the nearest cent, so I'm going to go for 33 cents here. So I'm going to say that this is $453,333.33. Okay, I need to also find out how much it costs to remove 90%. So same function, only this time I'm typing in 90%. and I've got 100 minus 90. So the question really at hand for this word problem is, what happens when you end up doing something more with, let's see, let's go back here. I'm going to delete this. Why won't it let me create? Okay, I'm having trouble. So 80,000, this is not what I wanted to have happen, times 90, and we'll put a decimal place after that, divided by 100 minus 90, and again, I'm going to make that a decimal, and I'm getting $720,000. Okay, so this one was $720,000. So it was a significant amount of money more for that 5% increase. So what's the additional cost is what they asked you for. So 72,000 minus $453,333.33 means that that additional 5% of removal of those pollutants, devilish here, is additionally costing companies an additional $266,666.67. Okay, let's hope the next problem goes better. Okay, for a person with sensitive skin, hello, that would be me, all my redheaded children, the amount of time T in hours the person can be exposed to the sun with minimal burning can be modeled by this function. So this is time. S is the Sensor scale. And so it can go between 0 and 120. Find the amount of time a person with sensitive skin can be exposed to the sun with minimal burning. We have three things we're looking for. You're looking for the different scale readings of 10, 25, and 100. So let's find the time for 10. There we go, 10. And so I'm plugging into my calculator. 0.37 times 10 plus 23.8, and then I'm dividing that by 10. And then I'm going to do this again for 25 and also for 100. And you're just replacing these numbers with a 25 or those numbers with a 100. So 0.37 times 25 plus 23.8, and then I'm dividing by 25. And then I would do the same thing with 0.37 times 100 plus 23.8, and then I'm dividing by 100. So I'm looking for three different values here. I'm going to calculate out one. Let's see, there we go. So if I plug in, I'm going to get an answer of 2.75 hours. Okay, so this would be 2.75 hours is what I'm talking about here. That's how long that person, it's a very low sensor scale reading. You could be out there for 2.75 without getting badly burnt. Go ahead and plug in the other values and see what you get. You can pause the video now before I give out the answers. Okay, 25, I got 1.322 hours. And then for a sensor scale, I got of 100, I got 0.608 hours. So that's about 40 minutes without getting severely burnt. Okay, follow-up question. B, suppose the model is valid for all values greater than 0. What would be the horizontal asymptote of the graph of this function, and what would it represent? The horizontal asymptote, well, the horizontal asymptote is taking those leading numbers. So I would look at 0.37s divided by s. And I would tell you that that's 0.37. And this is a horizontal asymptote. This is a y value. My y value is in time, so that would be hours. What does it represent? Well, remember, horizontal asymptotes are only good with extreme values of x. And so in this case, if my x values are really large, so if my sun sensor scale, if this goes to like really, really big numbers, like 120, you're talking about you can only be outside for about a third of an hour. So for about 20 minutes. So on a very extremely bright day with high sensor scale readings, you can only be outside for 20 minutes without sun damage. Moving on. A rectangular page is designed to contain 48 square inches of print. Rectangular page. Rectangular page. We're printing something. Look. And so it says it's got 48. The area here is 48 square inches. The margins at the top and the bottom of the page are each 1 inch deep. So top and bottom margins, that's 1 inch. And down here, that is 1 inch. The margins on the sides are 1.5 inches. Okay, so this is 1.5 inches. And over here, this is 1.5 inches. All right. What should the dimensions of the page be for the least amount of paper to be used? Dimensions of the page. Okay. So I'm talking about this side times that side. What are my dimensions to keep a minimum area, basically? All right. So I'm going to call this blue part X and this Y part Y. And so this distance here, down here, is this X plus this margin plus that margin. So those margins are, let's see, you get a 1.5, an X, and another 1.5. I'm going to call that X plus 3. Fantastic. Sorry, I had to cough. Going vertically, I'm going to call this Y, and then I have a 1 inch margin on the top and a 1 inch margin on the bottom. And so if I add those things together, I have really a 1 plus a Y plus another 1. So I'll call that Y plus 2 on this margin. So my area is really X plus 3 times Y plus 2. And I'm supposed to minimize this area. All right, well, that's a little bit difficult to do because you have 2 variables. Let's go back to what they told us originally. This rectangle over here is 48 square inches. How do I get that? Well, X times Y is 48. So really I have a system of equations here. I've got 2 variables and 2 that I need to kind of deal with. I need to get down to 1. So I'm going to rewrite this and say, well, let's change Y to be 48 divided by X. And I'm going to replace that into my equation right here. Okay? And so this new equation is really X plus 3 times 48 over X plus 2. I'm supposed to minimize this. And what I want you to see is that this is actually a rational function. So I'm going to distribute this like you're just foiling things out. This is, let's see, X times 48 over X is just 48. X times 2 is 2X. 3 times 48 over X is 144 divided by X. And 3 times 2 is 6. So if I simplify things here, I have a 2x, a 54, and a 144 divided by x. Let's get one denominator here. So I'm going to multiply, I have an x denominator here. So I'm going to multiply this guy top and bottom by x. So top and bottom by x. And this guy top and bottom by x. And so what happens here is that I get 2x squared plus 54x plus 144. And now everything had a denominator of x. So I'm going to look at this graph, and I'm looking for a minimum. I'm looking for a minimum. Okay. So if we go over here, oh, I thought I already entered it in. I apologize for that. Maybe I did. Is that in 0.5? Where'd it go? Okay, so here I go. So in here, I'm going to enter in, let's see, 2x squared, arrow over, plus 54x plus 144. And then I'm going to close my parentheses, and I'm going to divide by x. And why do I have that many parentheses? Let's go back here. I'm going to delete this, and then that should be all I need to do. Okay, so if I look at this graph, I don't see much. That's no good. Let's see. Tab, let's go up. I just want to make sure I entered this in correctly. All right, 2x squared plus 54x plus 1. Haha. Let's change that. Let's not do that. Oh, that is not what I wanted to have happen. Okay, so I need to go up here and I need to change this to 144. Good. Okay, so there's my graph. That's what I was looking for. I don't see a whole lot. My reality is that we're trying to create a piece of paper here, so I really only care about things in the first quadrant, and I don't see anything in the first quadrant. So here's what I'm going to do. I'm going to look at the table of values. So if I press Control T, I'm going to look at a table of values, and I'm looking for the area to be a minimum. I'm looking for this y value to be a minimum, and so I'm going to kind of go through here. I've got 200 if x equals 1. If I kind of keep going down, I'm looking for a smallest area. And it looks like it's somewhere, whoa, I love technology. It's so wonderful. It looks like it's somewhere between 8 and 9. So I want to find a minimum between 8 and 9 because all these other values seem to be going up and giving me bigger and bigger values. So I really want to look at a value between 8 and 9 is what's looking like my minimum is going to be. So I'm going to go back over here to my graph. So I'm going to do a Control T and get rid of my table. And I want to find out a minimum between 8 and 9. And I was all the way up at 88. So if I go to Menu, I can go to my window. I'm going to change things to my settings. I cared about something at 8. So this max gets me to 8, but I was all the way up in the 90s, so I'm going to maybe delete all of this, and I want to go up to like, I don't know, let's go 100. That'll take care of things for me. Okay, so look, I'm looking for some kind of a minimum around in that blue area between 8 and 9. So here's what I'm going to do. I'm going to go back to Menu. I'm going to analyze my graph. I want a minimum. And it's somewhere between 8 and 9 is what we found this to be. Whoops. So let's kind of go over here. This is not working for me. Let's try this again. I got to try this again. Minimum. See, technology is wonderful. We want to go to Analyze Graph, a minimum. Let's press Enter here, and then let's go over to, this is not working for me. I love technology. You're looking for a minimum, and this is not working for me. But I'm looking for a minimum, and I guess that's where I found it. Golly. Minimum. I want a minimum where x is between, right, 10, 8, and around 8. So this is my enter value, and then I want to go over here. This will work. God, I love technology. Ooh, I found one. Okay, there we go. 8.49 is what we're looking for. 8.49 is what we're looking for, okay? So when x is 8.49, my minimum y value is 87.9. Okay, so my minimum is x equals 8.49, and that gives me an area of that 80, what was it? 87.9. Okay, so this is my x value. I'm going to go back over here and plug in to find my y value. I'm supposed to find my dimensions. So y equals 48 divided by this 8.49, which means that is 5.66 inches. This is inches as well. Those are your two dimensions. Okay. That one was very, 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 very complicated. Don't worry about it too much. Wink, wink, nudge, nudge. A business has a cost function of this, where C is measured in dollars and X is the number of units produced. To find the average cost, think about an average. You usually add a bunch of stuff up, so plus, 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 and then you divide by the number of things that were added together, right? So if your cost is this equation, I'm going to divide by the number of things we created, okay? And so their average cost looks like this. Look, they divided by X. Determine the average cost per unit as X increases without bound. What does that mean? I want the horizontal asymptote. You've got 0.5x plus 500 divided by x. What happens when x is huge? Well, I just need this piece right here. What is 0.5x divided by x? That is 0.5, or 50 cents. So as I produce a ton of this thing, my average cost approaches 50 cents. Fantastic. That's all I had to do. Moving on. The cost in millions of dollars for the federal government to seize P% of an illegal drug as it enters the country is given by this equation. So the cost is the percentage of drugs that are seized. So I'm supposed to find the cost at 25%, the cost at 50%, and the cost at 75%. Okay, and so I'm going to plug in, let's see, 528 times 25 over 100 minus 25. How much does it cost to just get rid of 25% of the drugs that come through our country? Okay, so I plugged it in already there, and it's $176 million. $176 million. So this is 176, and that is millions. You're supposed to do the same thing for these other values. And I'm getting a different value than what I had originally. So if I plug in, oh no, I'm not. I just didn't calculate them. So if I plug in over here, same thing again, 528. And then I'm multiplying this time. I want to go to 50% times 50. And then close your parentheses. And then I'm going to divide by 100. Oops. Parentheses 100 minus 50. And I'm going to get 528 million. So this one gave me $528 million. And if I try to get all 75%, that's not all. If I try to get 75% of what's coming into the U.S., that is, $1 billion. $1,584 million. This was $1,584 million. Okay, according to this model, is it possible to get rid of all of the drugs that come in? 100%. So look at your possibility here. Oops, 528 times 100 over 100 minus 100. Please note that you are all of a sudden dividing by 0. So guess what? It is not possible to get rid of 100% of those drugs that are coming in. Okay. Last one here, the cost of producing C units, X units of a product is this cost C, and the average cost per unit is given by this. So here's your, this should be a C. I don't know why that's a Y. This is your formula again, and you're trying to plug in and find out what happens when you produce 1,000, 10,000, or 100,000 units. So I'm going to just calculate the cost for 1,000. I'm plugging in 100,000 plus 0.9 times 1,000 into my calculator, and then I have to divide by 1,000. And if you plug that into your calculator, I'm getting that it costs $100.90. $100.90. So this average cost is $100.90 if I produce 1,000 units. If you'd go back into your calculator and see, well, how much is it if I produce 100, I'm sorry, I was supposed to do 10,000 units. 10,000 units, you can plug that in. I find that it costs only $10.90. That's a lot cheaper. And then if I produce 100,000 units, all of a sudden my cost went down to $1.90. And so what happens here is that, man, the more I produce, the less my product costs. Part B says, by increasing your level of production, what's the least average cost you can obtain? Increasing how much I'm producing. This is a horizontal asymptote question. So 100,000 plus 0.9x divided by x. If I look for my horizontal asymptote, I'm looking back here. What is 0.9x divided by x? It is 0.9. You're talking about your average cost getting down to 90 cents. Okay, here's your homework for tonight. That's all I've got for you. Good luck. Be safe.